Explain block diagram of optical current transformer. So you can see the block diagram of a optical current transformer arrangement. So this diagram illustrates an optical current transformer, a device used to measure the high voltage electrical current using light instead of traditional magnetic coils. First of all, the operating principle is the system relies on the Faraday effect, where the magnetic field generated by the currents rotates the polarization of the light passing nearby. So optical electrical or say electronics units are also placed. You can visualize this. So the dashboard or the dash box on the left hand side represents the LV control unit, usually located safely away from the high voltage line. Light source. For the purpose or the functioning of this optical CT, the light source is required, and this block generates the initial light beam, typically a laser or to start the sensing process. Now the polarization is required, so a polarizer block is there. This component filters the light to ensure it travels in a single linear polarization state. Splitter is there, an optical coupler that allows the outgoing line to pass through the sensor while diverting the returning light or the signal to the electronics for the reading or the calculation or measurement purposes. Now a modulator is placed, which device modulates the light, that is often the phase modulation is there to improve the measurement accuracy and sensitivity of the current transformer. The sensing head it provides, or the sensing head means the above the or the top portion of the CT. The dash box on the right represents the massive unit or the passive unit placed directly on or near the high voltage infrastructure or say application or say CT. Circular polarizer is also there, which converts the incoming linearly polarized light into a circular polarized light, which is more sensitive to the magnetic field effects. The conductor. This is the high voltage wire carrying the current that needs to be measured. Optical fiber loop. A fiber loop is there. The fiber optical cable wraps around the conductor or serves the purpose of the CT secondary. As current flows, its magnetic field changes the light's polarization properties inside the loop, and the effect is measured by this loop or the secondary. Mirror. Located at the end of the fiber, it reflects the light back through the loop, doubling the path length and the sensing effect. Electronics or say generalized block of electronics, it is located back in the control unit. This block receives the returned light, converts it into the equivalent electrical signal and processes the data. Output. The final result is a precise digital or analog reading of the current flowing through the conductor, and it is generated as an output. So this is how the functional block diagram of optical current transformer serves the purpose of the current measurement or say step down current measurement at the substation level for the high voltage transmission lines.